Hello, we are currently sitting on Moon 6A in the STRANEOU MXK D8820 system. We are one jump away from our destination on this voyage, a stellar remnant in the STRANEOU RI-T P31149 system. I have opened the galactic map so you can see where this system lies in comparison with the Sol system. You can see that the destination is not far from the galactic center and quite far from Sol. I have therefore done a lot of traveling prior to this point. The destination is approximately 18,700 light-years from Sol. At an average of 70 light-years per jump, it has taken me and my Mandalay Stellar 266 jumps to get this far. Now let's lift off from this moon and head out so we can make the final jump to our destination.
Landing gear retracted.
As we aren't far from the galactic core, there is a lot of yellowish gas and dust, as it's much more dense in this region. We are also above the disk of the galactic plane. This is why we see a lot of this material below us. You can also now see the gas giant planet and the moon we lifted off from orbits around. We will do a fly past of this planet before making the hyperspace jump. Lined up with our destination. You can see that there is a blue-colored bipolar nebula there. Bipolar meaning that there are two opposing lobes of gas. Here they are in the left and right positions.
Frameshift drive
These gas lobes are usually aligned with the magnetic field of a star. arrived at the STRANEOU RITE-3 1149 system. Ahead of us is a neutron star. We will approach and get as close to it as we can. We reached the limit to how close we can get and have been forced to drop out of Super Cruise. Surrounding this system is a shroud of gas that is lit by the intense light and energy of the neutron star. This is the bipolar nebula that we saw just before jumping to this system. The presence of the neutron star and nebula indicates that this is the site of a supernova which occurred in the recent past. By recent, this means within a few 10,000 years, a blink of an eye in terms of astronomical timescales. A supernova explosion occurs when nuclear fusion in the core of a very large star, at least 8 times the mass of our star, the Sun, ceases. This means there is no more outward pressure holding the star up. As a result, the weight and gravity of the layers of gas above collapse inward. This collapse happens at a fraction of the speed of light. As the layers reach the core, they bounce off it, resulting in a cataclysmic explosion. The core, which is made of iron, is forced to compress to the point where the electrons in orbit around the nucleus of the iron atoms are forced to combine with protons in the nucleus. This produces neutrons. The result is what we see here, a neutron star. I will try to get as close to this neutron star as I can. Notice how bright the star is as we get closer. The gravity is also very intense. At about 1,000 kilometers from it, your body would be stretched as thin as spaghetti and then torn apart and atomized. The particles would impact the surface at nearly the speed of light, resulting in a tremendous release of energy. At 457 kilometers, we've hit the limit as to how close we can get. The 2 beams of light are coming from the north and south magnetic poles of the neutron star. These beams are caused by particles being accelerated to very high speeds by intense magnetism and the very rapid spin of the star. The rapid spin of the star twists the magnetic field lines into tight beams of energy. These beams are the most intense at the north and south poles of the star. It's at these points where highly charged particles are able to escape the gravity of the neutron star. This is why we are seeing these 2 beams of light here.
Frameshift drive charging.
We are now leaving the vicinity of the neutron star and are headed for a moon in orbit around a gas giant in this system. As we pull away from the neutron star, you'll notice the wobble of the twin beams of energy. This wobble is caused by the fact that the magnetic poles of most neutron stars are slightly off-center. As the neutron star rapidly rotates, there is a precession of the off-axis magnetic pole, resulting in a wobbling of the energy beam. Sometimes the Earth is lined up with one of these beams, which are also called astrophysical jets. As it wobbles, the jet points at the Earth, then away from it in rapid succession. This creates an on and then off beacon, much like a lighthouse. When this happens, the object is called a pulsar. As these pulses contain radio waves, we can hear and record them here on Earth with radio telescopes. We are now approaching the gas giant, which has several moons orbiting around it. One of those moons has a visitor's beacon on it, which is our destination. This planet and moons are lucky to have survived the forces that were associated with the supernova explosion that created the neutron star. This is likely because of its far distance from the original star. Even though it survived, it very likely did not emerge unscathed. This planet and moons likely looked a lot different than they did before the star went supernova. For instance, the ring system around this gas giant may not have formed until after the supernova. A closely orbiting moon could have been pushed inward by the force of the outward moving stellar material. It got too close to the gas giant, causing the gravitational tidal forces of the planet to pull it apart, thereby forming the ring system. beacon on this moon is located on the surface. We will enter orbit, drop out of supercruise, and then glide down to reach its location. As we get closer, we can see that this is an ice moon with large surface faults and cracks. These features are likely caused by internal heating. The heating comes from gravitational tidal forces from the gas giant stretching and squeezing the moon as it orbits. This is similar to the moon Europa around Jupiter in our solar system. We've flown to the dark side of the moon as this is where the visitor beacon is located. Even though we are on the moon's dark side, you'll notice that the surface is still somewhat lit by the glow of the nebula surrounding the system. The nebula's blue glow comes from the scattering of light from the intense energy being given off by the neutron star.
Mission objective complete.
Tourist Spot 89. This small nebula encloses a neutron star and in Commander Demificos' opinion makes a good celestial travel destination. As we depart this moon, you can see how thick the gas and dust of this nebula is in sections. This is an indication that it is still relatively young in astronomical timescales. But over time, as it continues to expand outwards, it will become more and more diffuse until it's barely visible. But that will take many millennia. Before beginning the long journey back to the Sol system, we will make one final approach to the neutron star. The plan is to approach the northern astrophysical jet, then stay in it long enough to use the highly energized particles and plasma within it to charge the frameshift drive. This will allow the ship to make its first hyperspace jump back home using very little of its onboard hydrogen fuel. We must approach carefully to avoid overheating. We must also stay out of the neutron star's exclusion zone while closing at the right speed. Too fast and we won't stay in the astrophysical jet long enough to charge the drive. I've adjusted my angle of approach to be as shallow as possible. This will increase the time we stay in the astrophysical jet. We are almost there. Once we are in it, it will be hard to control the ship. But this shallow approach angle and slow speed will help to stay in it long enough. Once the drive is charged, I will use the overdrive super cruise feature to quickly get out of the jet.
Warning, frameshift drive operating beyond safety limits. Frameshift drive supercharged.
Drive supercharge was successful and I'm lined up with the jump target, so it's time to leave this system.
Frameshift drive charging.
Before ending this journey, I'm going to swing around and point the ship in the direction where we just came from. This will allow us to see the nebula from a distance of about 70 light years away.
Complete.
As stated by the visitor's beacon, this is a small nebula, at least when compared to the grand scale of our Milky Way galaxy, such as the vast area of gas and dust in the galactic plane below the ship. That concludes this journey. I hope you found it interesting and informative. Until next time.